Hello and welcome back. So this video is for class 11 and we are going to start with chapter 4, motion in a plane. So of course the previous chapter was motion in a straight line, where we considered basically a one-dimensional motion. Okay, object moving in a straight line, either it is moving forward or backward. In this chapter we are going to consider the motion of an object when it moves along a plane. So we are going to consider the x-axis as well as the y-axis. Okay. Now for this particular chapter, you will need to know the concepts of scalars and vectors. So first, let us talk about scalars and vectors. Now of course you know very well, scalars, they are physical quantities which can be defined completely by the magnitude alone. Okay. For example, when we talk about the concept of mass. Okay. So if we say we are having an object that is having a mass of 100 grams. Okay, so that 100 gram, the magnitude, it is able to define the mass completely. We do not need to know which direction, correct? Obviously mass will not have any direction, so it does not require direction. Only magnitude is enough to give a complete idea. But if we talk about the concept, let us say force. Okay, if we say that we have applied a force of 10 newtons, so it is not enough just to give the magnitude. Okay, we cannot say we have applied 10 Newton force. We have to specify in which direction the force was applied. So these quantities, they are called as vectors. Okay, so that is the thing to know about scalars and vectors. So let us see one vector now. So if I draw a vector like this and let us call it as vector A. Okay, so this arrow, this denotes a vector, right? Looking at this, you can understand in which direction the vector is moving, and you will also know how much is the magnitude. The length of this vector will be the magnitude. And how do we denote it? If it is in the vector form, we denote it like this, A, and then there is an arrow put on top. To write the magnitude, we will write it like this. Okay, so if vector A is written like this in these parentheses, that means this is the magnitude. So how much is the magnitude of vector A? Magnitude of vector A is given by this symbol, or which is equal to simply A. Correct? So that is how we are going to denote a vector. Similarly, I am sure you remember the concept of a unit vector. A unit vector is a vector which has got magnitude of 1. Okay, and how do we find out unit vector? Any vector divided by its own magnitude, this gives us a unit vector. Okay, so vector A divided by magnitude of vector A, that will be a unit vector. Again, unit vector having magnitude 1 and direction same as that of the original vector. Now let us understand two types of vectors. One is called as a position vector and the other is called as the displacement vector. So to show the vectors, first we are going to draw a coordinate axis. This is the x-axis, this is the y-axis. So there is an object which is located here, for example. Let us call this point as P. This is the origin of the axis O. Correct. Now you can draw a vector going from the origin to the position to where that object is present. This can be for anything. It can be for example, where you are sitting and where the TV is. Correct. So from your point, you can see your point is the origin, and where the TV is, that point is the position vector, position P. So you can draw a vector going from origin to P like this. Okay, and this will be called as the position vector. Okay, so a vector which denotes the position of the object is known as the position vector. Generally, it is denoted by the symbol small r. It's not a rule or anything, but just for the sake of convenience, we are going to use the same denotions. So position vector we are going to show by the symbol of small r. So which is a position vector? OP. Now let us say the object is going to start moving. Okay, it goes from point P to some point P dash. Okay, now remember in this chapter we are considering a planar motion, that is we are going to consider x-axis as well as y-axis. So it could have moved on any point. For the sake of convenience, it goes from P to some point P dash. Now at P dash, what will happen? You will see the position vector will change. So now the new position vector becomes OP dash. Fine. And now you can see there is a vector going from P to P dash, that is this vector. This is known as the displacement vector. Generally, it will be denoted by delta r. Okay, so from point P to point P dash, the vector that we are getting, that is the displacement vector, and the vector which is going to point to their position, that will be called as the position vector. Okay, so this we called as r. So this OP dash we could call as r dash vector r dash. Getting the idea? So these two kind of vectors also you are supposed to remember. Now that we have understood about these type of vectors, now we are going to see some mathematical operations with regards to vectors. Okay, so let us start with them one by one. The first property we will talk about, that is the equality of vectors. So let us say you are shown two vectors, okay, vector A and vector B, and you have been asked to find out whether both the vectors are equal to each other. So what are the things you are going to consider? So let us say here I have a vector A, and here like this we have a vector B. Let us assume that both the lengths are the same. Okay, so we want to find out whether A and whether vector A and vector B are equal to each other. How do we find out? There are two things. One, two vectors will be equal if they are having the equal magnitude. Okay, so we can check how much is the magnitude of A and B. So let us take a very simple example. Let us say vector A is of 10 centimeters and vector B is also of 10 centimeters. So are they having the same magnitude? Yes. So we can say the magnitude is the same. But the second test we have to see whether they are in the same direction. Okay. Now you can see vector A is going like this and vector B is going like this. So that means they are not in the same direction. Correct? So because they are not in the same direction, and even though they are having the same kind of magnitude, we will say that vector A not equal to vector B. Okay. For equality of vectors, the magnitude should be the same as well as direction should be the same. So now let us see equal vectors. So if I have a vector A is going in this direction and very much parallel to it I have got vector B. Okay, now I see both of them are having same magnitude and they are moving in the same direction. Now for same direction they need not be coinciding. They could be moving parallel to each other, but still you will say the direction is the same. So if this is the case where both vectors are having same magnitude and moving in the same direction, now you will say vector A equal to vector B. Okay, so that is the test for equality of vectors. Next property we will talk about is multiplication of vector by a real number. So let us say once again we have a vector A and we are going to multiply this vector A by some real number lambda. Okay, now of course I don't think I need to explain what is a real number. So we are going to multiply vector A by a real number lambda. What will happen is when such a multiplication takes place, a new vector is formed. That new vector will have magnitude given by multiplication of lambda into magnitude of A. That means A multiplied by some real number will be equal to lambda vector A. Okay, this will be the resulting vector. The magnitude of this vector will be lambda into A and direction will be the same as that of A. Okay, so let us say we have some vector A which is equal to, we'll take a simple case, 10 meters along x-axis. Okay, so we are having one vector A that is of having a length of 10 meters along the x-axis. If we multiply this A by a factor of 2, okay, so vector A multiplied by 2, what will happen is we will get a new vector that will be 20 meters and same it will be once again along the x-axis. Getting it? Direction will remain the same but magnitude will change. That will be a product of the multiplying factor. Now for the important part, that is addition of vectors. Okay, now this is very important because you are going to see these additions after this chapter also and even when you come to 12th class also. Okay, so addition of vectors is extremely important. So now what we want to do, we are going to see how to add two vectors. Okay, so as usual we will consider one vector A and to this one vector A we want to add another vector. Let me make it like this, another vector b. Okay, so how to do the addition? Now of course you will know the addition of vectors will not be as simple as the addition of any real numbers. Okay, so 2 plus 2 if you are asked, so you say 2 plus 2 is 4. But if you have 10 centimeter of A and 20 centimeter of B, it does not give 30 centimeter of resulting vector. It is going to be much different. So how do you do the addition? So here is the method that you are going to do. For this, let me use a sketch pen. So let us imagine this is our vector A that is shown by the green sketch pen, and this is our vector B that is shown by the orange sketch pen. So when we want to add the vectors, if they are so far away from each other, we are not able to add. So here is what you have to do. Now this end, the backside, that is called as the tail of the vector, and this part that we call as the head of the vector. Okay. So this green pen, that is vector A. It is like this. Okay. Now here is vector B in this manner. When I want to add A and B, what we are going to do is bring the tail of the tail of B and touch it to the head of A like this. Okay, are you able to understand? A को ऐसे रख दिया. This is where B was. So to add them up, we are going to keep the vectors like this. We'll move this vector B so that the tail touches the head of A without changing the direction. Okay, like this. Now we are going to see this case, correct? Now what is the answer? What will be the resulting vector? Resulting vector will go from the tail of A to the head of B. That will be the resulting vector. Means here is, I'll try to make it here. So this is vector A. We'll try to bring B over here, and then B will be something like this. Correct. So now the tail of B is touching the head of A. Now what is the resulting vector? It will go from tail of A to the head of B here. Okay. Let us call this vector R. So this vector that you have got now, that is the result of adding A and B. So you will say that vector A plus vector B is equal to vector R. So this method of vector addition, this is also called as the graphical method or the triangle method. Okay. So please remember and make sure that you have understood how vectors are supposed to be added. Now let us see some properties of this vector addition. So what are the properties that we see? We see that the vector product, that is vector A plus vector B, will be same as vector B plus vector A. Okay, so whether doesn't matter to which end you are touching what. Okay, the final result will always be the same. So A plus B is equal to B plus A. Right? This property is called as commutative. So we say the vector addition is it has a commutative property. So A plus B will be equal to B plus A. Now let us say we are having three vectors such that if we have vector A plus vector B, and this vector we are adding to another vector C. So this will be equal to vector A plus vector B plus vector C. Okay, so this is called as the associative property. So doesn't matter how you are adding them. That is, let us say first you add A and B and then you add to C, or first you add B and C and that is added to A. The result will be the same. So vector, the addition of vectors is commutative as well as associative. Next, we will talk about the zero vector or the null vector. So what is a null vector? Obviously, you would have guessed. A null vector is a vector that has got zero magnitude. And how do you get a null vector? You simply subtract a vector from itself. So A minus A will be 0. Correct? So if you subtract a vector from itself, that will be called as a null vector. And what are some of the properties of a null vector? That if any vector is there to which a null vector is added, the answer, the resultant vector would be the original vector. Another property, that if you multiply any vector by the null vector, the answer will be a null vector. Okay, and of course if you multiply any real number to a null vector, the answer would once again be 0. So very simple properties of a null vector. So we spoke about addition of vectors. Now let us talk about subtraction of vectors. So once again, here we have vector A, and again like this we make it. This is vector B. Now we want to subtract vector B from vector A. That is, we want to find out A minus B. How do we do it? We are going to treat this as an addition only. How we will do it? We'll say this can be written as vector A plus minus vector B. Getting the idea? We can say that A minus B is actually addition of two vectors. First vector being A and the other one being minus B. And how do you find minus B? Minus B will be the opposite direction of B having the same magnitude. Means if this is B, minus B would go like this. This would be minus vector B. It is along the same line but in the opposite direction and magnitude will be the same. So how do you get A minus B? Once again, we make A like this. This is vector A. Now A has to be added to minus B. So this is minus B. So minus B could come here. So we could make it A, I'll make it here. So minus B can go like this. Okay, this is vector minus B. So the answer would be like this. The resultant vector R will go in this manner. Okay, so this is how you are going to subtract the vectors. Next, we will see the parallelogram method of vector addition. It is very similar to our triangle or graphical method, but it has got just one small change. So, what is the parallelogram method? We construct a parallelogram. So, let us say we have got two vectors, vector A and here is vector B. We want to add a vector A and B. So, instead of doing that previous method of graphical method, we will construct a parallelogram. And of course, you know what a parallelogram is. So, we will make a vector parallel to B. So, parallel vector will go like this. And we will make a vector parallel to A like this. Okay, so basically we have got a parallelogram now. And this diagonal will nothing but the resultant R. So, again, this R is nothing but vector A plus vector B. This particular method that is called as the parallelogram method of vector addition, and of course you will see it is very similar to the graphical method. Next we are going to talk about the unit vectors of the coordinate system. So here you see the coordinate system. This is the x-axis, this is the y-axis and this is the z-axis. Now z-axis is not along the board. The z-axis is actually coming outside like this. Okay, so but of course that we cannot show, so we have to show it in this manner. But please make sure that you are understanding x and y, they are on the board. Okay, along this line is x-axis, upwards is the y-axis, but z-axis is three-dimensional, it is coming out. Now, to understand this coordinate system in a much better way, we define some unit vectors along these axes. So, and of course, unit vector, you know, unit vector is nothing but a vector having unit magnitude, one magnitude. So, the unit vector along the x-axis, that is denoted by the symbol I cap, small case I. Then, unit vector along the y-axis is denoted by symbol J cap, and along the z-axis is denoted by K cap. Okay, I'll write it here. So, we have I cap, J cap and K cap. So, what are I, J and K? These are unit vectors and they have the direction along the axis. So, when you see I cap, you know magnitude is 1 and it is along the x-axis. J cap, magnitude 1 along the y-axis. K cap, magnitude 1 along the z-axis. And of course, if you read minus I cap, so minus I cap will be, it will go down layer, it will go in this direction like this, along the negative direction. Okay, so here also we can have minus I, minus J, minus K. Okay, so remember these three, that is I, J and K caps. Now of course you would be thinking, what is the reason that we talked about those I cap, J cap and K cap? Okay, here is the reason. We are going to use these factors for doing something called as resolution of vectors. Okay, and you will see this resolution of vectors is a very important thing which we are going to do many times after this. So what is resolution of vectors? Let me draw a vector A like this. Okay, this is vector A. Okay, we have drawn it such that it is coming from the origin. Now, to understand vector A, we can actually break A into two parts. Okay, how we can do that? We see that vector A goes here. So, it has got some part along the x-axis, right? Here, this part. We can call this part as AX. right? And similarly we can see vector A has got some part along the y-axis. Okay, that is here we can call this as AY. And of course now you can visualize that vector A is nothing but AX plus AY, right? If I call this as a vector, okay, this vector AX plus this vector AY is giving us the vector A, correct? And this is basically called as resolution. So any vector that you have, you can very easily break into 2 parts or even 3 parts. If we put the z-axis here, then we could write it as AX plus AY plus AZ, correct? That is called as resolution of vectors. But now here is the thing. In which direction is the vector AX? It is along the x-axis, that is I cap direction. And what about AY? It is along the y-axis, that is j cap direction. So now you can write vector A as vector A equal to AX I cap plus AY j cap. Okay, so this is the use of having unit vectors. We can denote vectors very easily, and it is very easy to visualize also in this manner. Okay, so you can write vector A as the x component AX into I cap plus y component AY into j cap, correct? So this is another representation of a vector, and this breaking down, that we call as the resolution of vectors. Now moving forward, so now what is the use of writing it like this? Okay, I will let us see. So this is a vector A and here is the x-axis. Let us say that the vector A is making angle theta with the x-axis. Fine. And then now we know the trigonometric ratios, correct? You can see that the cos of theta will be equal to adjacent upon hypotenuse. How much is the adjacent? Adjacent is AX upon how much is the hypotenuse? Hypotenuse is A. Or you can say that AX is equal to A cos theta, correct? Similarly, how much is sin theta? Sin theta is opposite upon hypotenuse. What is opposite? Opposite is AY, okay, and hypotenuse is A. So you could write AY is equal to A into sin theta, right? So using simple trigonometry, you could get a value for AX, which is A cos theta, and AY, which is A sin theta. Using these in our equation, we can write, therefore, vector A is equal to A cos theta I cap plus A sin theta into j cap. Okay, but still there is a better way to write this. Okay, so what we do, I'll erase this. We can write this as, if we write AX square plus AY square, how much will be AX square? AX square will be A square cos square theta plus how much will be AY square? A square sin square theta. A square will come out of the bracket, and what do you get? Cos square theta plus sin square theta, and we know very well cos square theta plus sin square theta is 1. So you can write AX square plus AY square is equal to A square, or you can say therefore A, that is the magnitude of our original vector, is equal to under root of AX square plus AY square. Okay, so it is very easy to find the magnitude of any vector if we know its x component and y component. Similarly, you will see that the tan of theta will be equal to AY upon AX, okay, opposite upon adjacent, or you can say therefore theta will be equal to tan inverse of AY upon AX. So you can find the angle as well. Okay, so this formula, these two, that is the formula for magnitude, A equal to under root AX square plus AY square. Okay, this you have to remember, and the formula for angle. What is the formula for angle? Tan inverse of AY upon AX. So basically you can resolve any vector into these two components, AX and AY, and you can get their values very easily. Okay, now next we are going to derive the law of cosines. Now this law is again very important when we are studying about vectors. So here is the situation. We have a vector A and vector B. Okay, we add them up and we get the vector R. Okay, now the angle between vector A and vector B is equal to this, that is angle theta. Okay, Now we want to find out a formula for the vector r. Okay. So here are some of the changes we have made. Okay, we have made the parallelogram OPSQ. Okay, this is the parallelogram we have made, and then we have made a perpendicular from S on the line N. So this is a perpendicular. Okay, so we get a right angle triangle SNP, that is a right angle triangle we are getting. Now to do the derivation. Okay, now there are many formulae you are going to see here, so pay attention. So first we start with the formula for R. How much is R? R is equal to vector A plus vector B. Let us call this our first equation. Fine. Now what we can write this as? So when we look at this triangle, that is the triangle OSN. This is a right angle triangle, right? So for a right angle triangle, you can use the Pythagoras theorem. So using Pythagoras theorem, you can write OS square is equal to the square of the sum of the sides. So what are the sides? Sn square plus this is On square. Now you can see On, it is made up of two parts, that is OP and Pn. So I'll write it like this. So it will be OP plus Pn square. This is by the Pythagoras theorem. So I got OS square, that is hypotenuse square, equal to Sn square, one side square, plus OP plus Pn in bracket square. Finally here, let us call this equation number second. Now, when you look at Sn, okay, so I want you to look at only one triangle, that is the S right angle triangle SNP. So when you look at SNP, if this is theta, then you can say that Sn is equal to, this will be equal to B, right? So you can say Sn is equal to B sine theta. How it is B sine theta? Sine of theta will be opposite upon hypotenuse. Opposite is Sn, hypotenuse is SP, that is nothing but B. So we know that Sn is equal to B sine theta, and also we know that OP is equal to A, and how much is Pn? In the same triangle you can see that Pn is equal to B cos theta. Okay, for this just very simple observation of trigonometry if you do, you can very easily figure it out. Pn, how much it will be? Cos theta is adjacent upon hypotenuse, adjacent is Pn, upon hypotenuse is B, that is nothing but the vector B. So using these, our equation 2 will become, okay, equation 2 will get, and of course OS is nothing but R, that will be the magnitude. So we can write OS as vector, this is only magnitude by the way, R equal to Sn square will be then B square sine square theta plus how much is OP? OP is equal to A plus how much is Pn? Pn is B cos theta bracket square. Fine, I hope this this formula you have understood. Now here notice, nowhere we have taken the directions, we are only talking about the magnitudes. So R is equal to B square sine square theta plus A plus B cos theta whole bracket square. Now if you open this bracket, what do you get? You get A square plus B square cos square theta plus 2AB cos of theta after opening this bracket, which here this will remain the same, B square sine square theta. Now how do you solve this? So if you look at this, A square plus B square cos square theta plus 2AB. So you can add B square sine square theta plus B square cos square theta. B square will come out of the bracket and you will only be left with sine square theta plus cos square theta, which will again be 1. So if you solve this, now this is something I want you to do on your own, you will get the answer as A square plus B square plus 2AB cos of theta. Okay, after you have solved that entire step. So you will get, of course, I made a mistake, this was R square. Okay, so you get R square is equal to A square plus B square plus 2AB cos theta. If R square is this much, then how much will be R? R will be equal to under root of A square plus B square plus 2AB cos theta. So any vector, if you know the you know the vectors that have made that vector, you can find out the magnitude by this formula. This is called as the law of cosines. Okay, so r equal to under root a square plus b square plus 2ab cos theta. This formula is very important. Okay, numerical can be asked on it, or as I told you, till 12th class you will be needing this particular formula, so make sure you have understood it properly.